So my talk today is about the journey we took almost 2 years ago, and the results I'll share with you. The thing is, the main part is the growth. And if this image is artificial, though this line on the background is not. So Preply is growing fast, 3 times, 2 times a year, year over year. And with the growth, there are a lot of challenges along the way, right? Even if it's desired outcome for the business, but for us as a technical part of it, it brings a lot of things along the way. The thing is that we are heavily relying on data. We are a data-driven company, and that means that we don't take or try not to take the decision that is not backed by data. Which means that we should gather it, analyze, bring some outcomes, and then take the decisions how to drive our product further. We were using Google Analytics, but as any vendor solution, this is how the vendor sees it, right? It's not the custom thing. And if we want to have the custom solution, we should implement it, right? So in this presentation, this story, I will show you what our first approach to gather the data and analyze it, what issues we have faced, and how we turned out this kind of growth obstacle, right, for us, as an opportunity to develop and build better solution for us, right? And to keep the service, level of service, not to drop it, not to compromise. This is the architecture of our first shot of the solution we've implemented to gather the data and to analyze it. As you see here, we have internal, external events. So internal means that they are generated in the application itself, right? And the external, they are also ours, but from the client. It's in the context of application, they are external, right? And here we're receiving them, fetching, like hydrating or making the event the look we want it to have. Then we're batching or kind of like offloading this from the application, storing them in this process stores them in S3 bucket. Oh, yes, Redis. Redis is in memory data store, uses database, cached, streamed, streaming engine, right? And the message broker. We're using managing services from AWS. We have one participant here. So slower. It's in memory, right? The most key thing here. S3 bucket or as Amazon Simple Storage Service is an object storage, right? And the Redshift, where the data ends, right, is a warehouse in the cloud, right? So there we analyze the events here. Yeah, okay. Pain points. What do you think? What were the pain points, or what might go wrong here? The right answer is everywhere. Like performance issues, right? We have here some processing happening, right? So for every event that comes to the application, we are querying the database, right? This is the dependency here. Redshift itself, right? You're constantly increasing the amount of data you're storing, analyzing it, and running different ETLs, right? Analyzes it differently. So it might be a bottleneck as well. Space constraints, right? Redis, we remember that it's in-memory data store, right? Data queue or anything, how you use it. And in-memory means it's you have it little, and it costs you a lot. And in the Redshift, right, depending on your configuration, the space also might be a constraint. Cost versus performance. Like with in-memory, costs a lot. We know that, kinda, right? Because the RAM much costlier than the disk. Though when you're scaling out Redshift, adding nodes, performance doesn't grow linearly, usually, depending on the design. But in the case of Redshift, it's in by design. Limited application time. You see here that we are when we receive the event, we trying to change it, right? To add the field, maybe to change to add some new fields, to change the event in total. And we are doing this for every request, but we don't store it. It's not persisted, right? If you did it wrong, we can at least corrupt the event, or we can lose it. The best case scenario, you just lose some fields, some values, but the whole event might go out. Here in the radius, let's say this background process, you have a bug here, right? So it pulls the events, but didn't store them. Depending on the logic you have in the application, you can just lose the all events, all the batch you fetched. Lack of data redundancy. The same goes here. You can override it, yes, and here. Oh, and by limited mitigation time, I meant that also if there is an issue, that means that you can run out of space in memory rather fast, right? And system rigidity. So you see here it's not kind of solid by the definition of the solid abbreviation. If you're interested in software design, a lot of things happening here. And this is the part you want to do your changes. You have new events, new things, you want to add them or maybe change somehow. So it's a dynamic part, but it's strictly coupled. So it only increases the possibility for you to introduce a bug or to corrupt the events, right? All this accompanied with the maintenance overhead, right? Sheer amount of alerts in every step, you can imagine. So it's not the great situation to be in. So the question, where do we start? To answer that question, or to give a hint how we're gonna walk along to resolving all this, I've chosen 4 dimensions. Tangible one, volume and velocity. It means volume, how the amount, the size of the event, right? And the velocity, the speed, how we accumulate it. And those two are multipliers. So you need to multiply them and to get the total. And the intangible too, value and importance. Value is the insights your data provides, you can get out of it. And the importance, whether or not you're using it, right? If it's in your processes, the data is very important, right? You cannot move without it, right? So the answer is Redshift, right? Why? Because here we have events to analyze, right? Where we have the value. And its most valuable part, it's dependent on this part, on these events to analyze, right? Or analyzed events. The value, we're getting the value of these events. We're getting the reports. The people are working in our company, here, based on this information, right? So this is the first part we should tackle. What is Redshift for data-driven company? Robust A/B testing framework is the first thing, right? It means hundreds of experiments, dozens of experiments metrics, calculated daily, hourly, Grafana, ad hoc queries, custom features, etc. Under the custom features, I mean that, let's say we have tutor analytics, right? To show something about their user performance or anything else, right? A lot of things. Bam. Initial configuration we had DC2 node type, right? It has, each node has 160 GB storage per node. And we were scaling horizontally due to space constraints or performance. which comes first. It looks like this. This is the compute node. Has its own dedicated CPU, memory, disk, storage. Compute nodes, store data, and execute queries, right? And it happens like schematically like this. Maybe you doubled your nodes, maybe you add the half, another bunch, another half, right? But where is the catch? Leader node manages the communication between compute nodes. It distributed the load, and here aggregates the results, right? So this is the point to the imbalance between scaling out your cost and the performance you're getting, because the load here, this guy works as, like, it just has more work, right? With each scale out. So leader node is the same size of compute nodes, but by design it's one. It doesn't scale with the scaling out technique, and it makes it a bottleneck for the whole cluster, right? And it got right. So how to tackle that? Scale up instead of scaling out. Same DC2 type nodes, but bigger. We're resolving performance issue here. Why? Because a lot less node means also the bigger master node. It's easier to cope with those, right? But we didn't solve the space and the cost issue, right? Because they are basically the same in terms of that parameters. So how we did the next step? Array 3 node types. Worth mentioning that the node basically the same. It has the disk and CPU and all the stuff, but it uses its internal disk as a warm cache. And then it has attached S3-like storage. So the storage is like quite drastically differs. So if there we had like 160 gigabit per node, here you can have like, I guess the smallest node is like 32 terabytes, right, of storage, which is like almost infinite in comparison. And by this migration, we also get cut the cost by a third. Why we moved? And that means that we moved to smaller nodes, right? Slower in compute terms. Why? Because some of the scales out were driven because we were lacking of space, not the performance. So we were bold enough to move not to the compare like CPU count or RAM count, right? So it would have cost more. We were bold to decrease the level of CPUs, right? And decrease the cost. And how we define performance here also worth mentioning. For us, it's not just like how fast the query goes, but whether or not our ETLs are green, right? If they are not hitting statement timeout. If the report is on table, it means the performance is sufficient. And we didn't stop on that, right? Why would we? Downscale the array 3 node twice. Because we have enough space, right? And we have our ETLs always passing. Why would we keep like paying more? Sorry, AWS, right? Okay, pipeline. So we tackled the issue with where the value burns, right? Let's us to concentrate on the pipeline itself. And under pipeline, I mean this part, like application, database, Redis, and this process which stores the data to S3 bucket. Pain points refresher. Everything stays as it was for this part. Performance issues, space constraints, cost, performance, limited medication time, lack of data, system rigidity, and maintenance. So everything is true for that part, right? And let's unwrap it. What are we gonna do? If we hear message queue, the answer is Kafka, right? All the answer today is like mainstream solution for any problem you have with messages, because of two parts for us. Like it's durable and data replace. And durable, what does it mean? Because you store or persist your events on the disk, right? and you replicate them as well, which means every client or different clients can get their offset and read the data as much as they want to, right? Okay, so let's build a new architecture with Kafka, right? Redshift ground process in S3 bucket, everything stays the same because here it's like recommended way of loading the data from to Redshift, right? It's efficient, fast, and it's internal machinery for AWS. But then let's focus on Kafka and start with creating topics, right? We have these internal, external events, so let's decouple them and create separated topics for both. Raw events, raw external events, and then we are calling it enriched events, right? Those. What it gives us, and how to get from one state to another, yep. It gives us the possibility to have the new entity, Kafka worker, right? Which gonna enrich the events, like do this process. And that means as well, in its subsequent turn, that we can offload the database, right? Instead, we can move this load from the application, right, the dependency, to here, like to Kafka worker when it's working batches, so it's more performant and it's not in application context. And also we can tackle this background process. So it also relies on Kafka, right? So it uses all the Kafka internal things we won't gonna touch because Kafka is ecosystem in itself. But the fun part that you can scale it quite easily as Kafka give us the possibility to do so. So we just connect those two. It's like stream, let's say. It pulls events from enriched and stores them in S3 bucket, which was the first load for this process, right? But what we're gonna do, how we're gonna address the application? First, we had this like one common endpoint. Let's just decouple it, right? What we're gonna do, and link to the Kafka, to the topic, to the dedicated topic, right? Not the one, but like two dedicated separate topics. What it gives us, right? It gives us the possibility to have a raw event, right? To persist the event without any changes, how we get it. And then to do some processing, changing, preparing it to be stored to the load. How we gonna test it, right? Basically very easy. You can just we created. We did that. We created the same tables as we have for production, same folders in S3 bucket, and just was writing in both data pipelines, right? So we tested it in production load. Every time, test in production. It's the best, my advice for you. Because you will face and you'll find all the bugs that real users have. So those mocks and stuff, it doesn't work. You just write in both and you'll see, and you'll gain from it. And then when you just switch the pipeline like to the new one, you can just delete the code. Don't leave the old code in the application because it hurts. Yep. Summary. So 2 years passed. I was long with this, like late with this presentation, but we can have better outcomes, right? Performance issues. So play points we saw before. ETL don't timeout. Queries doesn't cancel due to statement timeout, right? So performance is fine for us. We didn't scale out anymore, so we didn't add new nodes for the 2 years. Space constraints. Data stored in warehouse grew 3 times, right? And we have at the moment just 20% of disk utilized, storage utilized, right? Versus on the DC2 nodes, we had 90% usually, right? And if you just do the math and let's say you're scaling out 1.5 times every time, right? The lowest point of your utilization gonna be 60+%, right? And it's drastically the difference. cost versus performance imbalance. So if we have stayed on DC2 nodes, we would have paid 7 times more at that date just to feed the data, right? So our scale's gonna be caused only by the storage limitation, which we don't have with the new node types. Limited vacation time, like we were buying those hours, like minutes with the in-memory store, right? When you have something broken, and it was like 4 or 5 hours. So you need to jump to the incident as fast as possible, because when this time pass, you just start, Redis gonna evict the nodes and you'll lose the events. Now we have 7 days retention set, very comfortable. You can create Jira ticket, put it into sprint, no rush, right? Lack of data redundancy. We are storing the event raw. It doesn't change, you can replay it. If you have some bug, it's super easy just to change the offset to the first one, like it's in Kafka internal theme design, right? Because they are all on disk and you just can read it multiple times. So why don't you read it again, right? Application just proxy in the events and push them to the Kafka. Like no heavy lifting, everything good. Maintenance, I would have lied if I put mark it as a green one, right? You won't believe me. Because there are a lot of moving parts, right? Kafka, as I said, is an ecosystem on its own. And yeah, Kafka workers has these revokes and assignments, and you need to work with it to feel it, right? But we don't have alerts. Like if previously we had this situation when like the team which works on the Redshift complains you that, okay, we lack performance or we need to scale out, or we don't have enough space to replicate the data or to do some new things there. And or some alerts like triggering, and you should act fast on that, right? We just can right now have just the monitor to see, okay, there is some issue, let's fix it in like normal working hours. And that's it. No, but the key takeaway from this, right? Key takeaway that when you face the dragon, you can get out from it not only stronger, yeah, but with a system that serves you well, serves us well, right? And yeah, we can face the new growth. Thank you. Questions. High time for questions. If you have some. Pizza. Oh. I know that smell of pizza maybe drives you out of questions and you don't have any, but please.
Yeah. So my question is, did you explore Athena for the performance optimization from S3 before Redshift? Will it help there, or there was something that will limit you?
But why would we do that in the first place? We just have all the data and we just moved it as it is. It's like recommended way to load the data, and we don't read it over. We just have the new batch, let's say, of files, and we just move it there. And we don't need any sophistication there.
Yeah, like it wouldn't help in your case, the Athena, to read, like to execute queries faster in S3. It won't help for your use case.
Okay, execute the queries, but you have you should pay for that, right? So it's the different costs for reading the data, and it would have cost us much more.
Okay, thank you.
So what time once the raw you can analyze the raw data? How much time passed?
Okay, how much time passed from we received the event and we have it in the data store, right? It's completely customizable, but let's say we load every new batch in every 10 minutes. and it's done. We can have it like real time, almost real time, but we do that just to not to spawn a lot of processes. We don't need like it faster. Yep.
Hello? Yeah. So I wanted to know, in terms of the decision to go for AWS services, was that completely internal? Like, did you implement it on your own, or did you have support from AWS?
So we are hosting in AWS. Yeah, we're using managed services, but what does it mean under the implementation?
Designing the solution. So
Oh no, it's custom.
completely internal.
Yeah, of course, of course.
Okay, Redshift, it's not main database, it's like analytics engine, and I want to know your main application, like customer facing application, communicate with Redshift, or it's just for analytics and not for online data?
It does. It does. It's you're correct. It's all up, all AP, right? Analytical processing database, but we do have customer-facing themes there. You could use materialized views to make it fast, and there are different types of load you can do with the Redshift. So it has its own Korken features, and we use it. So yes, application connected with the Redshift.
So thank you.
Thank you. Thank you.